So 4.2, we are going to graph. Yesterday we graphed quadratics in standard form. Today we're going to graph quadratics in vertex or intercept form. And this is actually just going to be 4.2a because we're only going to do vertex form, which is really easy and it shouldn't take us very long. We're not going to talk about intercept form until tomorrow, okay? And then I'm thinking that Thursday I'm going to let you work on your worksheet. And then we're going to probably test Friday. And I'm thinking a 50-point test. All right, so let's compare all the different ways. So standard, this is what we learned yesterday, standard form. We're going to talk about what this looks like, okay? Vertex form. Oh, you're going to love vertex form. Everybody loves vertex form. You know why? You know why they call it vertex form?
Because it gives you the vertex.
Yeah, people, you like look at it and you scream the vertex out, okay? Like you don't even have to do anything. You just like, oh, I know the vertex, okay? And then intercept form, we're going to save it for tomorrow. Let's just take it easy today. Intercept form. Just a little warning, intercept form, you're going to have to know how to factor. Okay? So if you don't know how to factor, I'll teach you how to factor for like the second or third time that you've learned how to factor. Okay? And then, if you don't learn how to factor then, I'll come back and bite you in the butt a couple more times before you get out of this class. Okay? So, standard form. What does standard form look like? Y is equal to what? Perfect. AX squared plus BX plus C. Okay? So how do I find my vertex? H is equal to negative B over 2A. Very good. How do you find K? Plug it in. So then we're going to plug in H. And that will give us our vertex HK. Does everybody agree? We did that yesterday, and we just worked a problem before we started our video. We worked a problem, kind of a difficult one with some messy numbers. All right, so let me show you what vertex form looks like. Y is equal to A. Y'all, this A is the same A as this A. What is this A going to tell me? Tell me some things he's going to tell me. If it opens up or down. If it's positive, he'll open up. If it's negative, he'll open down. What else is he going to tell me? Yeah, if he's narrower or wider or the same. If the absolute value of this number is greater than 1, then he's going to be narrower. That's a vertical stretch. Okay? If the absolute value of this number is between 0 and 1, that's a vertical compression, and so that will make him wider. All right? So that A is the same A as this guy. So look at this. A times open parentheses, X minus H, quantity squared. That's what's making that quadratic. You see that X squared right there? Mm-hmm. And then plus K. All right? So, what's my vertex? H, K. That's it, people. H, K. What? That is so stinking easy. HK. Just shout it out. All right. Do you notice something that happened from here to here?
It changed to a positive.
Yeah, H changed signs, didn't he? Okay? So whenever you pull this guy out, you always want to change his sign. Okay? Now what about K?
It stays the same.
Yeah, he stays the same. So we're going to keep his sign. Okay, let me explain to you why this happens. Because you know why, guys. All right? This H is an X. Do you agree? Mm-hmm. Okay, he's with an X. He is an X. Where does he move?
Left or right?
Left or right. How does he move? Opposite of what you think. Do you see? That's what that's doing, guys. It's taking the opposite sign. Okay? So if I had a plus 2 here, where would that move?
Down.
To the left 2. And that would be a negative 2. You see? If I had a minus 2 here, that would move to the right 2, and that would be a positive 2. All right, what about this K? Well, he's a Y, right? He's not with an an X, so he has to be a Y. Do you see why I say this A is not with an X and he's a Y? It has to do with the vertical stretches and compressions. It's easier to see here because he's actually pulled out and not with the X. It's a little more difficult to explain why here. So Y's go up and down just like you think. So a positive will go up, a negative would go down, and that would be a minus. Okay? That's pretty easy, isn't it? That's all there is. There's nothing else. So let's work a problem. You ready? Example 1, graph. It's the only problem I'd like to do. Y is equal to negative 1/4 x minus 2, quantity squared, plus 5. People, we could slap this problem out in about 2 minutes if I wasn't talking to you. Okay, so there it is. Let's answer our questions because that's what your worksheet's going to do. It's going to ask you all of these questions, okay? So when I ask you the question, you write the answer down and then we'll talk about it. So write the answer down. Does this parabola right here open up or down? Write it down. All right, what'd y'all say? Down. Why does he open down? Yeah, A is negative. Okay, and if A is negative, it opens down. If A is positive, it opens up. Okay, write this down. Is it wider, narrower, or the same as the parent function? Is he wider, narrower, or the same as the parent function? What did you write down?
Wider.
Very good. Why is he wider?
In between 0 and 1.
Very good. The absolute value of this number is not greater than 1. That would make it narrower. Okay, that would be a vertical stretch. This is between 0 and 1, so it's a shrink, a compression, and that's going to make it wider. Okay, the next thing I want to know is, shout it out, people. Tell me what the vertex is.
2, 5.
Perfect. 2, 5. Change the sign and keep the sign. Change the sign and keep the sign. X's are weird, and they're always weird, and they always do the opposite of what you think. Change the sign. Y's are just like you think, so you keep your sign. What's my axis of symmetry?
2.
That is the most common mistake. And let me tell you what, there are 6 blanks on the first page, 6 blanks on the second page, and 6 blanks on the third page. You will miss every one of them if you do that. Do not make that mistake. What's wrong with it?
X equals 2.
X equals 2. It is a line. It is not a number. And you have to write it. Remember, we highlighted it yesterday when we talked about it. Okay? So I'm going to go over here and I'm going to graph it. 2, 5. 1, 2, 3, 4, 5. My axis of symmetry is X is equal to 2. Now what do I need?
Your side point thing.
Yeah, I need 4 more points, people. 4 more points. So I'll put me a little T-chart down here. Okay? I'm going to pick 2 X's. People, I don't care what X's that you pick, but I like to pick the X's. First of all, you only need to be on one side of the vertex. This is the vertex. You either want to go left and pick 2 or right and pick 2. I'm going to go left because it'll keep my numbers smaller. I'm always going towards the origin to keep those smaller numbers. And I'm going to pick the first 2 tick marks that I come to. What would that be? 1 and 0. Okay? When I work it, because I want you to show your work, when you work it, I don't want you to work it and then write the answer out here. Put your answer under your T-chart. Put your work out to the side. Okay? So, I got to plug this guy in. So I'm going to plug him in right up here. I want to know, what is y when x is 1? Well, it's negative 1/4 times 1 minus 2, quantity squared, plus 5. What's 1 minus 2?
1. Oh, negative 1.
Negative 1. What's negative 1 squared?
1.
1. What's 1 times negative 1/4?
0.25 negative.
Negative 1/4. Becky. That's what Becky, my daughter, always does. She always turns everything into a decimal. I'm like, stop, work with a fraction. Okay, so -1 plus 5. Y'all, what is 5 minus 1/4? Listen, your understanding of fraction helps with working with fraction, okay? I'm going to tell you two things everybody knows about. Food and money, okay? Everybody in this classroom knows about food and money. If I have 5 chocolate pies and somebody eats 1/4 of one of the chocolate pies, what do you have left?
4 3/4.
Very good, okay? Let me
We
tell
can
you,
write
if you
in
don't-
mixed numbers on the worksheets.
I like mixed numbers, especially when I'm graphing, okay? Now, let me tell you, another way to do it, if you're not into the chocolate pies. Maybe you like, money, okay? So this is 5 minus 1/4. Y'all, 5 minus 25 cents is what? $4.75, which is 4 3/4. Okay? Now, 0. Anybody know what the common mistake's gonna be on 0? Slapping down a 5. It is not 5. It's only this constant out here when it's in standard form like that guy up there is. Okay? So a lot of kids will get used to writing this down as 0. That's my y-intercept. And then when you go here, it's not. Because if you squared this binomial right here, which we're going to learn how to do tomorrow in less than 5 seconds. I'll teach you how to square this binomial in less than 5 seconds tomorrow. Okay? So then you'll have a constant on the end, a +4. You'll have to multiply by this, and then you'll have to collect it with that. So let's plug our 0 in. -1/4 times 0. Here I am. 0 minus 2, quantity squared, plus 5. What's 0? You got to do what's in parentheses first. What's 0 minus 2?
-2.
So I'll write it down up here. What's -2 squared?
4.
What's 4 times 1/4?
Negative
One,
1.
negative
1. Y'all, those are reciprocals of each other. Any number times its reciprocal is 1. And this is a negative times a positive, so it's going to be -1. What's -1 plus 5?
4.
Perfect. So at 0, it's 4. All right, so let's graph these. At 1, it's 4, 1, 2, 3, 4, and 3/4, almost to 5. So 1 to get to the axis and 1 to get away. I'm using that axis of symmetry to reflect my point through and pick up my other 2 points on the other side, so I only have to find 1. At 0, it's 4. 1, 2, 3, 4. So 2 to get to the axis and 2 to get away.
You said we could check them with the calculator, right?
Yeah.
Or just do it first?
Yeah, on your worksheet you can, but on your test you're not gonna be able to. So I'm just warning you, because I don't want you to be dependent on the calculator, okay? That's what's happening to kids. They're dependent on the calculator, and their math skills are not good, but their calculator skills are phenomenal. And then they go to college and some college professor says, oh, heck no, you're not using a calculator in my class. And then they flunk. So get comfortable without having a calculator. So here's my answer. Anybody got a question? Okay, so I'm going to give you the rest of the time in this class, which is like 15, 16 minutes, and you are going to work on your worksheets. Okay?